Question 1.1 consists of 5 questions designed to assess your general knowledge of measurements, maps and plans, and probability. You are given a table that lists the explanations and definitions of concepts used in mathematical literacy. You will have to use the information in the table to write down the letter of the explanation or definition of each of the following concepts. In question 111, the concept is BMI or body mass index. The explanation that describes this concept is E, a measurement of body fat based on the height and weight of an adult person. In question 112, the concept is circumference. The definition that best describes this concept is C, the path or boundary that surrounds a circular-shaped object or surface. In question 113, the concept is map scale. The explanation that describes this concept is I, the ratio of the distance in real life compared to the same distance on a map. In question 114, the concept is compass direction. The explanation that best describes this concept is B, the use of cardinal directions, that is north, south, east, and west, to describe the location of one point to the other. In question 115, the concept is tree diagram. The definition that best describes this is G, a special type of diagram used to determine the outcomes of an event in probability examples. Question 1.2 consists of 4 maps and plans questions designed to assess your understanding of layout plans. You are given a layout plan on Annexure A of a vegetable garden with different plant beds, as well as a table which shows plants with their partner plants. In question 121, you have to identify 3 plants that have cabbage as a partner. From table 2, 3 plants that have cabbage as a partner plant are potatoes, onions, and cucumber. In question 122, you have to determine the number of partner plants of plants found in bed 4 of the vegetable garden. From the layout plan of the vegetable garden, the type of plant found in plant bed 4 is onions. The number of partner plants of this type of plant is 6. In question 123, you have to name the partner plant which appears 4 times in the partner column. By inspection, we find that the partner plant which appears 4 times in the partner column is beans. In question 124, you have to give the compass direction of sage from the onions in the vegetable garden. On the layout plan in Annexure A, we note that the arrow points down towards the bottom of the page, indicating that north is in that direction. This means that south is directly opposite to this direction or towards the top of the page, east is to the left of the page, and west is towards the right of the page. So the compass direction of sage is about southeast from the onions in the garden. In question 125, it is stated that some of the plant beds in the vegetable garden contain more than one type of plant. You have to write down the plant bed numbers of these plant beds. From the layout plan on Annexure A, we note that plant bed 3 and 7 have more than one type of plant. Question 1.3 consists of 3 measurement questions designed to assess your understanding of dimensions and volume of cylindrical objects. You are given sketches that show a pedestal and a diagram of the pedestal with its dimensions. The pedestal can be used as a table, plant stand, or as extra seating. We note that the diameter and the height are equal at 124 millimeters. In question 131, you have to choose a formula A, B, or C which can be used to calculate the total volume of the pedestal. Note that in each formula r equals the radius and h equals the height. In formula A, volume equals 2 times pi times r times h plus 2 times pi times r squared. In formula B, volume equals 2 times pi times r squared times height. And in formula C, volume equals pi times r squared times height. For this question, we should recall that the definition of the volume of a cylinder is the base area of the cylinder multiplied by the height of the cylinder. This means that the area of that base is given by the formula pi times r squared, where r is the radius of the circle. Note that r is half the diameter of the circle. Now the area of pi r squared must be multiplied by the height of the cylinder. This will give us the volume of the cylinder. From the list of formulas given, we see that this formula matches the definition of the volume of a cylinder. So C is the correct answer. In question 132, you have to write down the unit of measurement for the volume of the pedestal using the given unit in the diagram. The unit of measurement given in the diagram is millimeters. We should know that the unit of measurement for volume is cubic units. So the unit of measurement for volume of the pedestal using the unit given in the diagram is cubic millimeters. In question 133, you have to convert the height of the pedestal to meters. From the diagram, we note that the height of the pedestal is 124 millimeters. We should recall that there are 1000 millimeters in 1 meter. So 124 millimeters equals 124 divided by 1000, and this equals 0,124 meters. Question 1.2 consists of 5 maps and plans questions that were designed to assess your understanding of assembly diagrams. It is said that ring lights are the best lighting options for close-up photography and videography. Ring lights are used for projects like makeup sessions. In Annexure B, you are given an item list and assembly instructions for a ring light. Some of the instructions have been omitted. In question 211, you have to determine the total number of items needed to assemble the ring light. From the item list, we count 5 items that are needed to assemble the ring light. In question 212, you have to identify in the list the item that will be used as the ring light stand. From the item list, the item that will be used as the ring light stand will be the tripod. In question 213, you have to state whether the direction of the arrow in diagram B is clockwise or anti-clockwise. Usually the conventional way of tightening items like screws or bolts will be in a clockwise direction, meaning in the same direction as clock hands in an analog clock. From the diagram, the instruction tells us to tighten the cell phone holder. Also, the arrow points in a clockwise direction. So the answer is clockwise. In question 214, you have to match the following instructions with the correct picture F, G or H. In question 214a, the instruction is to clamp the cell phone to the cell phone holder. From the assembly diagram, we note that H matches this instruction. In question 214b, the instruction is to install the tripod on the pan tilt and rotate until tightened. From the assembly diagram, the image that describes this instruction is G. Question 2.2 consists of 2 maps and plans questions that were designed to assess your understanding of map scales. It is stated that the scale used on a whole map in a classroom is 1 to 250,000. In question 221, you have to use the given scale to determine the distance on the whole map if the real distance is 65 kilometers. We should recall that this type of scale is called a numerical scale. It gives us the ratio of map distance to the corresponding distance in reality. It means that 1 unit on the map equals 250,000 units in reality. Normally, we measure map distance in centimeters or millimeters. And since this question didn't say whether we must give the answer in millimeters or centimeters, it's safe to assume that you can decide whether to write the answer in either one of these units. For this question, we will provide the answer in centimeters. For start, we convert the 65 kilometers to centimeters. We should recall that there are 100,000 centimeters in 1 kilometer. So 65 kilometers equals 65 multiplied by 100,000, and this equals 6,500,000 centimeters. Now, using the scale factor of 250,000, we calculate the map distance by dividing the distance in reality of 6,500,000 by the scale factor of 250,000. This equals a map distance of 26 centimeters. In question 222, you have to name one other type of scale used on maps. Another type of scale used on maps are bar scales. Question 2.3 consists of two questions designed to assess your ability to solve a combination of measurement and maps and plans questions. It is stated that a mathematical literacy teacher collected 36 reams of paper from her learners. You are given a picture and a diagram with the dimensions of a ream of paper. The teacher intends packing the reams of paper in a secure cabinet as shown in this picture. The dimensions of the maximum space on one shelf are 102 centimeters long, 44 centimeters wide, and 39 centimeters high. In question 231, you have to show with calculation that all reams of paper collected can fit on one shelf of the cabinet. The first step is to calculate how many reams of paper can fit into the cabinet space lengthwise. This will be the length of the cabinet of 102 centimeters divided by the length of one ream of paper of 27,94 centimeters, and this equals 3,65. This number needs to be rounded down to 3. The reason why we round down and not up is because 4 reams of paper cannot fit into the 102 centimeter length of space. But if we round down, the 3 reams of paper will fit into the space. There will be a little bit of space left over, but that's okay. Next, we have to calculate how many reams of paper can fit into the cabinet space widthwise. This will be the width of the cabinet space of 44 centimeters divided by the width of one ream of paper of 21,59 centimeters, and this equals 2,04. This number needs to be rounded down to 2. So 2 reams of paper can fit widthwise in the cabinet. Next, we have to calculate how many reams of paper can be stacked height-wise. This will be the height of the cabinet of 39 centimeters divided by the height of one ream of paper of 6,35 centimeters, and this equals 6,14. This number must be rounded down to 6 reams of paper. So 6 reams of paper can fit height-wise in the cabinet space. Now the total number of reams of paper that can fit in the cabinet space is the product of 3 reams lengthwise by 2 reams widthwise by 6 reams heightwise. And this equals a total of 36. In question 232, you have to give one reason why the teacher would like to pack the paper in the cabinet. One reason could be to keep them clean and dust-free. Question 3.1 consists of 4 measurement questions designed to assess your understanding of perimeter, area, and volume of rectangles and rectangular prisms. It is stated that Unati bought a house. 2 of the walls in one of the bedrooms were not plastered. The dimensions of the floor of this bedroom are 4,8 meters by 3,5 meters as shown in the diagram, with a wall height of 2,75 meters. Unati intends having these walls plastered. Note, plastered means that the walls are coated with a sand and cement mixture to create a smooth wall surface. In question 311, you have to calculate in square meter the total surface area of the 2 walls that need to be plastered. You may use the following formula: area of a rectangle equals length times width. From the information provided, we know that there are 2 walls to be plastered. One has a length of 3,5 meters and a height of 2,75 meters, and the other wall has a length of 4,8 meters and a height of 2,75 meters. The formula that was given lists the length and the width, but we should recognize that the width in this formula actually refers to the height of the wall. Now the surface area of wall 1 is the length of 3,5 meters multiplied by the height of 2,75 meters, and this equals 9,625 square meters. Next, the surface area of wall 2 is the length of 4,8 meters multiplied by the height of 2,75 meters, and this equals 13,2 square meters. So the total surface area to be plastered is 9,625 square meters plus 13,2 square meters, and this equals 22,825 square meters. In question 312, it is stated that the plaster on the walls has a uniform thickness of 12 millimeters. You have to determine in cubic centimeters the volume of the plaster required to plaster these two walls. You may use the following formula. Volume of the plaster equals the area of the walls multiplied by the thickness of the plaster. Since you are required to give the answer in cubic centimeters, you have to convert both the thickness of 12 millimeters to centimeters and the total surface area that was calculated in question 311 of 22,825 square meters to square centimeters. Converting the thickness of the plaster to centimeters, we should know that there are 10 millimeters in 1 centimeter. So 12 millimeters equals 12 divided by 10, and this equals 1,2 centimeters. Next, converting the total surface area of the wall, we should know that there are 10,000 square centimeters in 1 square meter. So 22,825 square meters is 22,825 multiplied by 10,000, and this equals 228,250 square centimeters. So the volume of the plaster is the total area of the wall of 228,250 square centimeters multiplied by the thickness of the plaster of 1,2 centimeters, and this equals a volume of 273,900 cubic centimeters. In question 313, it is stated that the ready-mix plaster is available in bags. One bag is needed for every 15,000 cubic centimeters. You have to determine the minimum number of bags needed to plaster the two walls. From question 312, the required volume of plaster was calculated to be 273,900 cubic centimeters. The number of ready-mix plaster bags required to cover this volume is 237,900 cubic centimeters divided by 15,000 cubic centimeters per bag, and this equals 18,26 bags. Since we cannot buy 18,26 bags of ready-mix plaster, we have to round this value up to 19 bags, because rounding down to 18 will result in less ready-mix plaster than required, and we cannot buy 18,26 bags of plaster. If we round up to 19 bags, you will have enough plaster to cover the required volume. In question 314, it is stated that Unathi would like to have all the old cornices in the bedroom where the four walls meet the ceiling replaced. You are instructed to calculate in meters the total length of all the new cornices. You may use the following formula. Perimeter equals 2 times the sum of the length plus the width. From the diagram showing the bedroom dimensions, the length of the room is given as 4,8 meters and the width of the room is given as 3,5 meters. So the perimeter is 2 multiplied by the sum of 4,8 meters plus 3,5 meters, and this equals 16,6 meters. Question 3.2 consists of 3 probability questions. It is stated that Unathi is advised to choose a specific brand of ready-mix plaster to prevent dampness in the walls. In question 321, it is stated that at the store there are 5 available brands. Unfortunately, Unathi forgets the name of the specific brand. If she randomly selects one of the available brands, you have to determine the probability that she will select the specific brand. The probability that you will select the specific brand is 1 brand over 5 possible brands. This equals 0,2 or 20%. In question 322, it is stated that there is a 0,75 probability that the dampness will appear if the incorrect brand of ready-mix plaster is used. You have to determine the probability that the dampness will not appear if the incorrect ready-mix plaster is used. The probability that the dampness will not appear if the incorrect ready-mix plaster is used will be 1 minus 0,75. And this equals 0,25 or 25%. In question 323, it is stated that the probability scale below shows the likelihood for various probabilities. You have to write down the likelihood that best describes your answer given in question 322. On the probability scale, the omitted percentages on the scale are these, and the answer to question 322 was 0,25. or 25%. So the likelihood that best describes the answer given in question 322 is less likely. Question 3.3 consists of 3 measurement questions designed to assess your understanding of time, temperature, and imperial to metric conversions. You are given the instructions on the ready-mix plaster. You will have to use this information to answer the questions that follow. In question 331, you have to determine the time that Unnati must start mixing the first bag of ready-mix plaster if she wants this bag to be ready to use at 8:05 in the morning. From the instructions, it takes 4 minutes to achieve a good consistency when we mix the water and plaster together. Then we have to allow the mixture to stand for 3 minutes for additives to dissolve. Finally, we have to mix again for about 2 minutes. This gives us a total preparation time of 9 minutes. Subtracting this prep time from the time that she wants the bag to be ready for use at 8:05 in the morning will give us a start time of 4 minutes to 8 in the morning. In question 332, you have to calculate rounded to 2 decimal places how many gallons of water will she use to mix 5 bags of plaster if 1 gallon equals 3,78541 liters. From the instructions, we know that 7 liters of water is required per bag. Multiplying this amount by 5 bags will give us a total of 35 liters of water. Since 1 gallon equals 3,78541 liters, the total number of gallons needed will be 35 liters of water divided by 3,78541 liters per gallon, and this equals 9,24602619 gallons. Rounding this value to 2 decimal places will give us 9,25 gallons. In question 333, it is stated that the plaster reaches its full strength 21 days after it has been applied at room temperature of 73,4 degrees Fahrenheit. You are instructed to convert this temperature to degrees Celsius. You may use the following formula: degrees Fahrenheit minus 32 degrees equals 1,8 multiplied by degrees Celsius. Since we have to calculate the temperature in degrees Celsius, we can rearrange this given formula such that degrees Celsius is the subject of the formula. We do this by dividing both sides of this formula by 1,8 to give us degrees Fahrenheit minus 32 degrees divided by 1,8 equal 1,8 multiplied by degrees Celsius divided by 1,8. Now the 1,8 in the numerator cancels with the 1,8 in the denominator, giving us the formula degrees Celsius equal to degree Fahrenheit minus 32 degrees divided by 1,8. Now substituting the value of 73,4 degrees Fahrenheit into the formula will give us a temperature of 23 degrees Celsius. Question 4.1 consists of 2 maps and plans questions designed to assess your understanding of layout plans. You are given a layout plan of a holiday resort. The resort has a rectangular swimming pool and a tennis court. There is an overgrown area in the middle of the resort where local wildlife can be viewed from the lookout point. This area is surrounded by houses. In question 411, you have to determine the total number of houses in this holiday resort. Simply counting the number of houses on the plan will give us a total of 12 houses. In question 412, it is stated that a person standing at the lookout point facing north views the houses that are in a northwesterly direction. You will have to give the numbers of two of the houses he viewed. Given that north is in this direction, northwest will be halfway between west and north. The possible houses that he viewed are houses numbered 1, 2, and 12. Any two of these houses are accepted as correct. Question 4.2 consists of 5 measurement questions designed to assess your understanding of volume, surface area of cylinders, and rectangular prisms. It is stated that the owner of the holiday resort planned to build a cylindrical pool. You are given pictures that show the existing rectangular pool and a cylindrical pool which the owner plans to build at the holiday resort. In question 421, you have to give one reason why you think the cylindrical pool is designed for small children. One reason that could be given is that the depth of the cylindrical swimming pool is only 1 meter deep, therefore making it ideal for children. In question 422, you have to explain the meaning of capacity of a swimming pool. Capacity is the maximum amount of water the swimming pool can hold. In question 423, you have to calculate, rounded to the nearest liter, the difference in volume of the two swimming pools. You may use the following formulae. Volume of a cylinder equals 3,142 times the radius squared times the depth. And the volume of a rectangular prism equals the length times the width times the depth. We can start by calculating the volume of the cylindrical pool. To use the formula for a cylinder, we will need the radius of the cylindrical pool. From the dimensions of the cylindrical pool, the diameter of the pool is given as 7 meters. We should recall that the radius of a circle is half its diameter. So the radius of the cylindrical pool is 7 divided by 2, and this equals 3,5 meters. Substituting the values of the radius and the depth into the cylindrical formula will give us 3,142 multiplied by the radius of 3,5 squared multiplied by the depth of 1 meter, and this equals 38,4895 cubic meters. Next, we calculate the volume of the rectangular pool. Substituting the length of 6,2 meters, the width of 3,25 meters, and the depth of 1,65 meters into the formula for the rectangular prism will give us a volume of 33,2475 cubic meters. Next, we calculate the difference in the volume between these two pools to be 38,4895 cubic meters minus 33,2475 cubic meters, and this equals a difference of 5,242 cubic meters. Finally, we have to convert this value from cubic meters to liters. From the note given, 1 cubic meter equals 1,000 liters. So 5,242 cubic meters equals 5,242 multiplied by 1,000 liters per cubic meter, and this equals 5,242 liters. In question 424, it is stated that the total inner surface of the cylindrical pool will be tiled. An additional 10% tiles were purchased. You may use the following formula. Surface area of an open cylinder equals 3,142 multiplied by the radius multiplied by the sum of the radius plus 2 multiplied by the depth. In question 424a, you have to give one reason why additional tiles were purchased. One reason could be to allow for breakage during the installation of the tiles. In question 424b, the tiler states that they require more than 100 boxes of tiles to complete the tiling. You will have to verify showing all calculations whether his statement is valid. The first step is to calculate the surface area of the pool. Substituting the values of the radius of 3,5 meters and the depth of 1 meter into the given formula for surface area, then simplifying the equation will give us a total surface area to be tiled of 60,4835 square meters. Next, we divide the total surface area of the pool by the dimensions of one tile that is given in the information provided. We should note that we just calculated the surface area in square meters, while the dimensions of the tile is given in centimeters. So we will first have to convert the dimensions of the tiles from centimeters to meters. We should recall that there are 100 centimeters in 1 meter, so 20 centimeters is 20 divided by 100 centimeters per meter, and this equals 0,2 meters. So the dimensions of one tile is 0,2 meters by 0,2 meters. Now the surface area of one tile equals 0,2 meters multiplied by 0,2 meters, and this gives us a surface area covered by one tile of 0,04 square meters. Now dividing the total surface area of the pool by the surface area of one tile, we can calculate the number of tiles needed to tile the pool. This equals 1,512,0875 tiles. Now remember that an additional 10% of the tiles were purchased for this tiling project. This means that they will need 110% of the tiles needed to complete this project. That is 100% of the tiles needed plus an additional 10% for breakage. So the total tiles to be purchased will be 110 divided by 100 multiplied by 1,512,0875 tiles, and this equals 1,663,29625 tiles. This value needs to be rounded up to 1,664 tiles, because if we round down to 1,663 tiles, we will have less than the additional 10%. But if we round up, we will have slightly more tiles than 10% additional tiles, but that's okay. It's always better having more material than less material for a project. Finally, we have to calculate the number of boxes that needs to be purchased by dividing the total number of tiles needed by the number of tiles per box. So 1,664 tiles divided by 16 tiles per box, and this equals 104 boxes. Since this value is more than the stated 100 boxes, we have to conclude that the tiler's statement is valid. Question 5.1 consists of 4 maps and plans questions that were designed to assess your understanding of route maps. It is stated that Laundry, Neo, and 3 friends plan to drive to Sani Pass in KwaZulu-Natal. They will travel from Johannesburg and stay in Mkomazana. Annexure C shows the route map to Mkomazana. In question 5.1.1, you have to write down the road number on which they will travel from exit 99 to Bulwer. The road number according to the route map is the R617. In question 5.1.2, you have to give the distance from Underberg to Heimville. From the route map, the distance between these towns is 6 kilometers. In question 5.1.3, it is said that after driving 2 kilometers from Heimville, the road splits to the left and the right. You have to state in which direction, left or right, they must drive. From the route map, after driving 2 kilometers from Heimville, they must turn left to go to Mkomazana. In question 5.1.4, it is said that it is 16 kilometers from Heimville to Mkomazana. The distance between Mkomazana and the hotel is 4,4 kilometers. You have to calculate how many kilometers after the split in the road the hotel indicated with H on the map is located. The distance from the split to the hotel is the difference between the total distance of 16 kilometers and the sum of the distance from the hotel to Mkomazana of 4,4 kilometers and the distance from Heimville to the split of 2 kilometers. This equals a distance of 9.6 kilometers from the split in the road to the hotel. Question 5.2 consists of 2 maps and plans questions and 1 finance question. It is stated that Mkomazana offers 2 sleeper and 6 sleeper accommodation options. The rates given in table 3 are per cottage per night. In question 5.2.1, you have to give a possible reason why there is a surge on a single night stay. One reason could be to encourage spending more days at the venue. In question 5.2.2, you have to name with a reason the cottage you would recommend for the group to book. According to the information given in question 5.1, we know that there are a total of 5 friends. Thus, the Valley or Coot cottage will be suitable for a group of this size. The reason for this recommendation is that it will be cheaper to rent a 6-sleeper compared to 3 2-sleepers. In question 5.2.3, Neo stated that the total cost for the accommodation will be 8,100 Rand if they stay in the cottage from Thursday to Saturday night. You have to verify showing all calculations whether his statement is correct. Since we established that the group will be taking a 6-sleeper cottage, the cost for Thursday night will be 2,640 Rand because Thursday is one of the days that is classified as a midweek day. Then the cost for Friday and Saturday night will be 2,730 Rand multiplied by 2 nights, and this equals 5,460 Rand. So the total cost for the 3 nights will be 2,640 Rand plus 5,460 Rand, and this equals 8,100 Rand. Since this equals the amount stated by Neo, we have to conclude that his statement is valid. Question 5.3 consists of 3 maps and plans questions, 1 measurement question, and 1 finance question. It is stated that Annexure C shows the route map from Johannesburg to Durban. You are given the tollgate fees for the Johannesburg to Durban route. The group of friends will be traveling in a Land Rover. The vehicle has a fuel consumption of 6.42 liters per 100 kilometers and a seating layout as shown. In question 5.3.1a, you have to indicate whether the following statement is true or false, and if it's false, you have to give a reason. The statement N3 is the only road on the map with toll gates. This statement is false because the map shows other roads that also has toll gates. In question 5.3.1b, you have to indicate whether the following statement is true or false, and if it's false, you have to give a reason. The statement is, Howick is on the eastern side of Lesotho. From the map, we know that east is to the right because Durban is a city on the east coast of South Africa. Therefore, it is true that Howick is on the eastern side of Lesotho. In question 5.3.2, we have to state the view represented in this layout picture. This view is known as an aerial view. In question 5.3.3, it is stated that the distance from Johannesburg to Mkomazana is 588 kilometers. The Land Rover covers this distance in 7 hours. You have to calculate the average speed of this vehicle. You may use the following formula. Distance equals speed multiplied by time. Substituting the values of distance and time into the given formula will give us the equation 588 kilometers equals speed multiplied by the time of 7 hours. Dividing both sides of this equation by 7 hours will give us the equation 588 kilometers divided by 7 hours equals speed multiplied by 7 hours divided by 7 hours. Now the 7 hours in the numerator cancels with the 7 hours in the denominator, giving us speed equal to 588 kilometers divided by 7 hours. This equals an average speed of 84 kilometers per hour. In question 5.3.4, it is stated that the accommodation petrol and tollgate fees for the round trip to Mkomazana will be shared equally amongst all group members. You have to calculate the total cost per person. You may use R21.40 as the fuel price per litre. We know that from question 5 to 3, the total accommodation cost was verified to be R8,100. Now for the total petrol costs, we know that the fuel consumption of the vehicle was given as 6.42 litres per 100 kilometers, and the total distance to the resort was given as 588 kilometers. We were also given the price of the fuel per litre as R21.40. So the first step is to calculate how many 100 kilometers there are in 588 kilometers. This will be 588 divided by 100, which equals 5.88. So the amount of liters of fuel consumed by the vehicle was 6.42 multiplied by 5.88, and this equals 37.7496 liters. Since the price of the fuel per liter was R21.40, the total cost of the petrol one way will be R21.40 multiplied by 37.7496 liters, and this equals R807.84. Since this is a round trip, meaning the group traveled to the resort and back home, the total cost to and from the resort will be R807.84 multiplied by 2, and this equals R1,615.68. Next, we have to calculate the total tollgate fees. From the route map, we note that there are 4 toll gates the group have to pass on the N3. The fees for the toll gates are given here. The tollgate fees to the resort will be the sum of these tollgate fees. Note that they won't reach tollgate 5 as the group will be exiting the N3 at exit 99, which is after Howick. So the total tollgate fees one way will equal R273. Since this is a round trip, we will have to multiply this cost by 2, giving us a total of R546. Now the total cost will be the sum of the cost of the accommodation, petrol and tollgate fees. This equals a total cost of R10,261.68. Finally, the cost per person will be R10,261.68 divided by the 5 people in the group, and this equals R2,052.34 per person. Thank you for taking the time to watch this video, and if you found this video helpful, please like and share to help others like you, and you can subscribe to get notified of more videos like this. If you want to learn more, you can check out this video next.